And welcome back, Mindsetters. Hope you have a nice little break. In fact, no, not even a break. You see, I've been doing these shows for too long now. Now every show just blends into the next one. But anyway, welcome, Mindsetters, to this session of Grade 12 Learn Extra. I hope you guys got your pens and pads out and you're ready to make notes. I have Phil here with me, who's back with me, who was doing the Grade 10 show earlier. And now we're ready to do this Grade 12 session. So I hope you guys have gotten your pens and pads ready and you're going to make some notes. But on that note, Phil, what are we doing today?
Okay, well, today's a little bit of an interactive lesson. We're going to be doing some revision of last year's physics paper. This is going to be one of 4 revision sessions, and today we're going to be taking apart the November 2011 paper.
All right.
Okay.
So, on that note, while you make your way across the board, I'm going to tell the Mindsetters, you know the drill. Make sure that you get on the page. Make sure that you start posting your questions. I know you guys have got major exams coming up. No pressure, though. That's why we're here. You guys need to post your questions if you're lost and if you need help. I will be also making sure that I post some diagrams for you guys. So, on that note, I'm going to hand over straight to Phil, who's going to continue the show. Phil, take it away.
Thank you so much, Ty. Okay, well, grade 12s, as I said, we're going to be taking a very, very close look at the November 2001 paper 1. So we're going to start off with a little bit of physics. What I've decided to do is I'm going to be taking you through the multiple choice question 3, question 4, question 5 today, and we're going to leave the next piece of physics until 2 weeks' time. So we're going to take apart this physics paper. So what I've asked Ty to do is actually start posting up these questions. I've tried to make them the same size that you can read them on your cell phone or you can read them on your computer, however you're following us, and you can actually answer these with us. And I'm going to be reasoning my way through all of these questions piece by piece. So I want you to follow through with us, take down some of our answers. This paper is available on our website. It is available on the Thutong website, and we're going to be posting it in tiny bits and pieces. So you can actually follow through with us today, and I want you to try these questions before I even get to the right answer. So I want to make sure that you guys are doing this with me. You're writing down the correct answer, and who knows, maybe you learn something new and there's something that you didn't know before or something that you didn't really understand. Okay, so I'm going to be walking you through some multiple choice questions in questions 2, and I'm going to be asking Ty from now on in to start posting these bits and pieces. So question 2.1, question 2.2, question 2.3. So he's going to be posting those up on the Facebook page. So watch out for those. Okay, now I just wanted to give you a little bit of advice before we climbed into these multiple choice questions. Gives myself a little bit of time to get into this and tie some time to post up some of those questions onto the page. But I need you to make sure that you're approaching multiple choice in the correct way. Because for a while there was no multiple choice in the final paper, but in the last few years it's come back in a big way. And it's in there, it's 2 marks a piece, and there are 10 of these questions. Now, that's a big chunk of your final paper. And I want to make sure that you're going about this exactly the right way. Okay, now all of them start out with some sort of statement or diagram, and there's 4 options. Now some people say, okay, well this is multiple guess. That is not the way that I want you to approach this. Now, there's a couple of ways to approach these, and the way which I prefer to do this is without looking at the answers first. That is the ideal way. Now, all of these have got answers which you're just looking to find. Now, I'm going to show you what happens if you don't find one of those answers, if you're really, really stuck, and it does turn into a sort of like, well, I think it's that one, but it might be that one. Okay, so what we're going to do is we're going to take a look at the first one. I'm going to show you what my approach means. Okay, so what I'm going to do is I'm going to suggest that you don't even look at the options before you've thought of an answer. So what we're going to do is we're going to take a look at the important pieces of information, and let's see how this works. Okay, so question 2.1. I'm in there and I'm busy with my physics final and the pressure is on. And just to remind you guys, your finals are coming up, so you better pay some attention. Okay, so question 2, November 2011, these guys are stressing. How do we get rid of that stress? How do we go through multiple choice without it being painful? Okay, well, the first way to make sure that they can't trip me up with some false answers is to make my mind up before I read any of these options. Okay, so let's start to deal with some of these things. Okay, the first one is a definition. So let's deal with some of the numbers. Okay, so number 2.1. All right, so now first of all it says impulse is equal to the. Okay, now I want you to start thinking about what is impulse? What is impulse? Don't start taking a look through the options. They're going to misguide you. And that's what those other options are there to do. Now, those other options are there to sound as if they're right. Okay, and the problem is that they all kind of do sound right. They all kind of sound sciencey. You've got a little bit of physics terminology. That's not the way to do this. Don't go looking for the answer. Know the answer, and then try and match it up with A, B, C, or D. So let's do this. Impulse is equal to the. Well, I remember that impulse was kind of something to do with momentum. And if you remember that impulse is the change in momentum, that gives me a starting point for taking a look through this. Okay, well, let's take a look. I would sit there with a pencil, and we can cross off the ones which we know are incorrect, and we can leave ourselves with ones which we think are. Okay, well, impulse is equal to the initial momentum. I'm not entirely sure the word momentum is in there. It's a maybe. The final momentum of a body. Okay, well, that doesn't sound quite right either. Okay, C, the change in momentum of a body. Okay, well, this is starting to look a little bit more, sort of sane. Okay, I've got an idea of what's going on here. It's something to do with momentum. Then the rate of change in momentum of a body. Okay, well, this is all starting to look a little bit familiar. But what I'm going to do is I'm going to make my life a little bit easier. Okay, so my first approach didn't work. I thought that impulse was something to do with change in momentum, and everything had momentum in. So what do I do now? What I'm going to start doing is I'm going to start crossing out things which I'm fairly sure that I know they're incorrect. Well, I know that impulse is not an amount of momentum. My brain said that it was a change in momentum. And the ones which I thought would be correct would be C and D. So let's get rid of option A. All right, so it's not the initial momentum of a body, because that is just the initial momentum of a body, nor is it the final momentum of a body. So it's not option A, it's not option B. Now we're left with a 50-50 choice, and that really improves my chances. Okay, so now let's start to take a look at some of these other bits and pieces. The change in momentum of a body. Well, that was my first option, so I think I've got option C. But now let's just investigate option D and check if that might be right. The rate of change in momentum of a body. Okay, well, if I'm not entirely sure, what I can actually do is grab my formula sheet and I can say, okay, well, rate of change in momentum. Well, let's actually make a sum which says the rate of change of momentum. Delta P, which is change in momentum, and to make it into a rate, I'll say delta T. But hang on a second. I can find this on my formula sheet. My formula sheet tells me that that is a formula for finding the resultant or net force of something. So D is incorrect. Okay, now that should show me something. I should have gone with my gut feel initially. Change in momentum in an object was right all along. But what we did was we very cleverly eliminated all the other options. Okay, I knew that it wasn't the initial or the final momentum of a body because those were exactly that. I thought it had something to do with the change in momentum, but they threw in option D. Option D was there to confuse me. So what I did was I changed it into something which I knew, and I looked on my formula sheet, and I saw that the rate of change in momentum of a body was actually the F-res, or the F resultant. My initial guess was correct. So option C was my first answer. I know with confidence that that's the right answer now. So what I'm going to do now is I'm going to move onwards to my next question. Now this one's a real challenge. Okay, so question 2.2, and I hope you guys are following at home. Okay, now let's see what's going on inside this question. I'm going to highlight some of the important pieces of information. It says, an object is pulled along a straight horizontal road. Okay, that's pretty important. So straight horizontal road, there it is. I am being told that it's being pulled horizontally. To the right, okay? So that's important as well, because we now know where it's going without being lifted. So it's not being raised off the ground. The force diagram shows all the forces acting on the object. Let me just highlight what they are, because it's kind of difficult to see, and they're nice and small. All right, so let's take a look. What have we got? We've got F, which is the applied force. We've got N, which is the normal force. That's the floor pushing back up on the block. And we've got W, which is standing for the weight of the object, and we've got small f, which is the friction of the object. Now, it says the force diagram shows all these forces. Great. Now it says which one of the above forces does positive work. Oh, well, now I've got a little bit of a problem. Okay, well, first of all, before I even get tangled up by the idea of positive work, let's figure out what work is itself, okay? So grade 12s, you know all about hard work. You're busy hard working at the moment. So what we're going to do is we're going to take work and try and figure out how to calculate that. Well, work needs a force. More than that, right? If I take a force and I multiply it by some sort of displacement, and I've got cos of the angle in between them. Okay, the only way that I can get a positive version of this to come out, now that's the formula for work. The only way that I can make this positive is if over here I've got displacement and force in the same direction. Now that should be a little bit of a clue. Well, now using just this information, I can increase my chances of winning. Here's how. I know that displacement and force must be in the same plane of motion. That's a little bit of a hint. You cannot do work if there's no displacement and force acting in the same direction. So we were told that it was horizontal. Okay? So that means that vertical forces cannot do work. So let's get rid of them. N and W. So the normal force and weight are not going to do any work here. So that's option A and option B right out of the window. Okay, now what I've got to do is I've got to start to think, well, how on earth am I going to get this to be positive work? Well, now here's your definition for positive work, and you might want to write this down. Is positive work is when the force and the displacement are in the same direction. Okay, so let me just repeat that. Force and displacement are in the same direction. That means that the force is helping the displacement happen. Okay, well, remember earlier on it told me that I was moving odds to the right. There we go. There was my information. Only one of these forces is actually helping me do that. And here it is. There it is, my applied force, and that is option D. I know that for sure, but there's always some doubt. What about frictional force? Friction is also horizontal. How do I make sure that that's not the one for me? Well, I know that if displacement is to the right and friction is to the left, I can actually work with this equation. If I really want to make sure, if you put in cos of 180, let me show you where the 180 comes from. If I've got my displacement in one direction, so there's my displacement, but the force is in the other, the angle between my displacement, so there's my displacement, delta x, my delta x and my applied F, that is 180. Go ahead and put in cos 180. What you will find is a negative value. That means that I've done negative work. That's proven that I've chosen the right one. So now I've made doubly sure that friction is not the one for me, because friction does negative work on objects. Right. In general, friction is always going to do negative objects. It always takes energy away from an object. Okay, so we're doing pretty well. Usually you guys wouldn't stop and consider this so carefully, but sometimes you get a little bit of time at the end of the exam, and I want to make sure that everything is correct, so that none of the other options could actually be right. Okay, moving onwards. So we're doing fairly well. We're fairly sure of our first few answers. Okay, now comes along a really weird graph. Okay, now I'm pretty sure that the metrics kind of freaked out a little bit when they saw this graph at first, but it's actually easier than we think. Slow down, breathe, let's start reading together. So a ball is released from rest. Okay. So I know that initially this object is being released from rest, from a certain height above the floor. Okay? And then it bounces off the floor a number of times. The position time graph below represents the motion of the bouncing ball from the instant it is released from rest. Okay. Now, what we've got to do is we've got to identify where all this information fits onto my graph. Okay? So what I'm going to do is I'm going to highlight what happened in the beginning. In the beginning, we were told that there was rest. Okay? So this is when the ball is dropped. Now, the reason that this position time graph looks so strange is because it's upside down. So what starts to happen is as the ball falls, I can see that the ball is falling over there. What happens at point A? There's a sudden change in velocity from a positive slope to a negative slope. And that sounds a lot to me like this ball was bouncing. So what happened was it bounced at A. Okay, I can see that along the same displacement or the same position, I see another similar point. So I know that A and C must be where the ball bounced. Okay, So now I know that A and C are actually representing the floor. Now that's what's kind of weird about this graph. A and C are points which represent where the ball is bouncing. How did I know that? Well, what I needed to know was that I started off from there, position 0. What happened? I went away from position 0, and then I bounced and came back to position 0, but not quite. I came nearly as high. Okay? So position B and D are the places which are far away from the ground. Okay, let's just go through that again. That was really confusing. So what I'm going to do, I started off from rest. This is where I begin. What you've got to do is realize that they actually tell us some information over there. I released it from rest. So that's where we begin our story. Then from a certain height above the floor and bounces on the floor a number of times. Okay, well, I see multiple bounces on here. And bouncing would always happen on the same place, and that's on the floor. I see that A and C are the same position. Now, let's read the question. It says, neglecting air resistance, which point, A, B, C, or D on the graph represents the position time coordinates? Now, that sounds so complicated. So basically, they're saying where on the graph would we find the maximum height reached by the ball after the second bounce? Well, let's first identify which bounce was which. So bounce number 1 we saw was A. Bounce number 2 was option C. Well, we know that the bouncing is not going to be the maximum height. So we already know that options A and option C are completely out. So what we've got to do now is we've got to choose between B and D. Now they say the maximum height, but make sure that we read the points which are in capital letters there. It says the second bounce. So bounce once at A, bounce twice at C. The only point which is remaining is option D. Okay, once again, I think I've got my right answer. Let's just make sure that the other one can't be correct. Well, option B is the maximum height on the bounces, but it's not after the second bounce. It's after the first bounce. So there we go. We've got option D. There we go. And that is my correct answer. Okay, we're moving on pretty well. And I think we've got time for one before we take an ad break. Okay, now this I particularly like because this is an interference pattern. Let's take a look at this. So it says water waves pass through a double slit. Let's just take a look what they're talking about. Anytime they tell you about something, look at the diagram and say, okay, where are these slits? Okay, well, we've got slit number 1 over there. So let me just highlight it. This is where the waves are coming through. Remember that when you send waves through a small opening, they turn into round waves, and that's called diffraction. It's going to happen again through this next part. So now we've got 2 places where waves are becoming round. Okay, then what happens is those waves are going to cross over each other. It says the resulting circular wave fronts produced are shown as dotted and solid lines. So it all looks very, very confusing. And what I'm actually hoping is that my producers actually got this on the screen. And you can actually see that the troughs and the crests are different lines. My crests are solid lines, while my troughs are dotted lines. So let's take a look and see what they're asking for me. So they say which one of the points, A, B, C, or D, lies on nodal lines. Okay, what did I say to you in the beginning? Choose an answer before you even look at the options. So this word nodal, okay, well, I've got to be very careful that I understand and remember what nodal actually means. If I remember from grade 10 and from grade 12, I know that nodal means that where there is destructive interference. Oh, so what I've got to do is I've got to find a place where destructive interference is going to take place. Okay, now destructive interference, I've got to remember how to get that to happen. Well, destructive interference happens when I've got a crest and a trough, so 2 opposites which meet each other. Okay, well, let's take a look. Let's take a look at our options here. Let's see where that might happen. Firstly, option A. So option A over there, let's highlight it. Option A has got 2 dotted lines. That means a trough and a trough. Now that means that option A has got two troughs. That will be constructive interference. Two of the same, constructive. So definitely not option A, because that's going to be a constructive wave. Okay, what about option B? Option B, well, I can see from option B that there are two solid lines. That means that I've got a crest and a crest. Crest and crest, same things, constructive again. So option B is off the table. What about option C? Well, option C says to us that I've got a solid line, which is a crest, and a dotted line, which is a trough. I think we're in business. What we've got is two different things which are crossing each other. Okay, so a crest and a trough, when those guys cross each other, fantastic. That means that I've got destructive interference. But once again, just to make sure, let's make sure that option D is not something that we can choose. Option D over there, we don't have two waves. We've only got one crest, one solid line. So there cannot be interference when there aren't two waves. So option D is off the table. So once again, we've confirmed that option C must be the correct one. Okay, I think these guys need a little bit of a break. This is getting a little bit intense, eh?
It is, but what I'm enjoying is that they are following along, so that's great.
That's fantastic, Ty.
So on that note, Mindsetters, make sure that you keep chatting to us on the page. Make sure that you keep posting. And so you know, I have posted up the questions for you guys, so make sure you look at that. It's in the albums called Grade 12 Physics Revision. All nicely laid out for you guys, so you guys can click on and follow with us. But on that note, this is where I say, I'll see you after this ad break.